This is a milliohm meter. It can measure resistance, the series resistance, up to 2 ohms. So natural, your next question would be, why would I need a device that measures only 2 ohms if I have the one that can measure mega ohms? Excellent question. Let's answer it. Hello friends, welcome back to the bench. Thank you very much for joining me. Today we're going to take a look at my new device and my new tool, which is a milliohm meter. So now let's consider, what do we need this device for? Do we even need it if we have a professional multimeter which measures resistance? Here we have a GPU. This is relatively old GPU, so that's going to be perfect for this presentation. What we want to know on GPUs is whether the core is shorted. Is it a piece of wire or is it actually working? Now on this card, this is not hard because we just connect black probe to the ground and the red probe on one of the coils on V-core. And as we can see, our resistance is 5.9, 5.8 ohms. So the core is fine. The core is not shorted. But this is pretty old card. The new cards, more powerful cards, the core is going to be no different than the piece of wire. This meter is going to tell us 0. So let's take a look at some more powerful GPU. This is Alienware, I think this is M16R1, I'm not sure. We have i9 CPU and we have 4070 GPU. 4070 GPU is going to have a lot less series resistance. So if we perform the same measurement on this one, we are reading 1.1 ohm, which is still within the range of this meter. 1.0, 0.9 right now, because the caps are charging. And it's going down. Looks like it's going to stabilize on 0.9. But anything from experience, speaking strictly from experience, anything lower than say 0.8 on this meter is highly unreliable. You cannot measure 0.2 on this meter. And in many cases, you want to see 200, 300 milliohms on some devices, especially on GPUs. So that is the main reason why we need a meter that works in that little region, and that narrow region between 0 and 2 ohms. Right? Now let's take a look at the device, and as you can see, we have 4 wires coming from the device. Now why is that? That was the question I asked, because I've never seen that before. Now as you can see, those wires go into the clips, and one goes up, one goes down. So that clip has 2 wires. Why would we need 2 wires on those clips? The answer is actually pretty self-explanatory. First, let's understand the problem. If we connect these two, we can see that the meter says 0.2, 0.3, 0.1, and 0. Right? That's why it's so unreliable. But it went down to 0. So our probes should have 0 resistance, but do they? What we can do is use the meter to actually measure the series resistance of the probe itself. So we're going to clip one at the end over here. We're going to turn on the meter and we're going to touch this one over here. And the answer is 26. 26 milliohms is the resistance of our probe. And you can see relatively stable. I'm holding it with my hand, so it's kind of fluctuating by 1 milliohm, but that's only because I'm touching it. Which means our actual resistance, no matter what you measure, even if you just short 2 probes, the resistance is going to be 25 times 2, so 50 milliohms. If we just touch single wires together, as you can see, nothing happens. Now why does nothing happen? Because first the meter is going to measure the resistance between those 2 wires. So we basically want to zero in on this one on this point and this point. Then whatever resistance we're reading between those 2 points, that's the resistance we're interested in. But we have to reduce the overall resistance reading by the resistance on those wires. So that basically allows you to remove or ignore the resistance of the wires. That means those wires can be as long as you need them to be. These are relatively long, but not huge. But you can replace them with much longer wires, should you need to. And that's not going to affect anything, because our resistance is always measured between those 2 points, regardless of the length of the wires. That is a brilliant design. This is the first time I see it. And it blew my mind how simple it is. No more calibrating the probes for every time you change them. Now here we have an ESR meter. This is different technology, although it will still report resistance in ohms, but that's not the series resistance, or at least, well, it's a series resistance equivalent. That's why it tells you in ohms, but it actually uses frequency to push the wave into the wire and see how wire reacts. That's why it's so useful to test the capacitors. You cannot test capacitors on DC because capacitor will charge and will no longer allow current flow. So to actually measure the capacitor, to measure either capacitance or series resistance, you need to use AC to charge and discharge the capacitor. This device, as opposed to our regular meter, it requires calibration. So we have a 0 over here. The way you calibrate it, you short together the probes the best you can, and you hit 0, and it says that error zeroing because the probes, the cables, are too long. Now, why does it say that? The cables are not long, right? Let's see the original cable. The original cable it came with, and my replacement cable. As you can see, the length is very close. Obviously, mine is a little longer here with that needle, but it's similar size. So why would the meter say that the probes are too long? Well, let's test them. So I'm gonna put one at the very end. That's how we measure. Well, almost the very end, as far as I can. And the other one here. And our resistance is pretty significant. At the moment, roughly 250 milliohms. So quarter of an ohm. So 2 probes are going to give us half an ohm. That's huge. Now the original one, if we do the same, clip one on one side and the other on the other side. Oh, we lost one because it's round. And we have 18, 17. That's a lot better. It's still not perfect, but it's going to be very hard to bring it down to 0. There's always going to be some resistance. But 16 is perfectly fine. 250 is a big no-no. Part of it is because it used to work, but this needle just oxidized too much. There's too much gunk on it. There is a gold banana plug over here, but there's no gold in there. So again, we're having a lot of friction on those contacts over there. And this steel. So if we want to just check the steel alone, I'm going to clip it on one side here and the other side over here. And even here on this short route, we're almost 40 milliohms. That's why this probe doesn't work. Now, you might ask question, what would be the best probe? The probe that I always use on my Fluke, as you can see, it is electroplated with gold. So if I perform the same experiment here, as you can see, 1 milliohm, next to nothing. And if I put them even closer, we should go down to 0. So this is a good probe. That's why I use it. This is not, and I built it a long time ago, and it did work for a while. It actually did work for a long time, but now it doesn't. It oxidized, the cable maybe lost its properties, maybe oxidation on the socket over there, the oxidation of the wire over here, maybe some other things. The contacts obviously between the wire and the socket over here and over here, that could have oxidized as well, and that also impacts the resistance. So now let's measure the actual GPU between the ground and the coil. So what we can do, we can just clip it on one of the ports to catch the ground. Then what I do is I use my very good probe. I clip it like this and I touch the coil. And now remember that our meter showed 1 ohm, around 1 ohm. It's actually 550 milliohms, which is correct. For this GPU, 500 milliohms is fine. This reading can go as low as maybe 120, 150 milliohms, but anything lower than that is suspicious. Because remember that if we now connect between one ground and the other ground, we have, well, now we're over, poor connection. We have 2 milliohms, right? So if you see this for maybe 6, maybe even 10, that is a piece of wire, because that wire will always have resistance. So if you're reading non-zero, that doesn't mean it's not shorted. If you're reading 20 milliohms, that is low. You should read at least, in my view, obviously depending on the GPU, but you shouldn't read less than 100. It should always be 3 digits. These digits should always be at least 1. Now, likewise, this meter cannot go above 2 ohms. So that is perfect for me because this meter is perfect above 2 ohms. To measure 6 ohms, 8 ohms, 10 ohms, it's pretty good. But for 2 ohms and below, I do not trust this meter. And the main reason is that we do not have a calibration of the probes. I'm pretty sure you can calibrate the probes on this one somehow. I'm not sure. Or maybe it self-calibrates somehow. I'm not sure. But it is not designed for such applications of measuring less than 2 ohms. And now back to our 6 ohm GPU. So if we try to measure high resistance, so let's connect to ground and again on the coil, and we are showing, well, we're showing over, right? Not even. So if I touch it to the ground again, let's see which one is the ground. This should be the ground. That's the resistance between one ground and another ground, right, on the board. So this is basically just resistance of the board itself. But if I touch it where it says 6 ohms, as you can see, nothing's happening because the resistance is too high. Now, if you're curious, what is the voltage that this device uses? And does it use frequency or is it just typical DC? I'm pretty sure it's just normal DC. It's 4.023 volts that we're sending. Now, is there a frequency? Let's check. It is steady DC. The scope says 427. Our meter said 4.020 something. As you can see, different devices will give you different answers. That is normal. In that region, in that precision range, you can have some fluctuations depending on the device. None of my devices are really high end, and none of my devices are really designed to be super accurate. If they're accurate within 200 millivolts, 300 millivolts, I'm fine with that. I don't need much more than that. But as you can see, no, there is no frequency, there is no signal. It's just pure DC signal coming from, or DC, a DC current or direct current coming from the meter, nothing more. So all it does, the entire idea of this device, or the entire usability of this device, is just we're measuring between those 2 points regardless of the length of the wire, and we're measuring resistances between 0 and 2 ohms. That's all it does, and it does it well. Now, as far as the price of this, it's below 50 bucks. I think it was like 40 something on AliExpress. I'm sure you can get it for maybe 60, 70 bucks on eBay from United States. It is not battery powered. It has lithium ion battery. The charger is USB Type-C, but you can't connect just any charger. It has to be 5-volt regular charger. It doesn't negotiate the voltage. So if you connect the laptop charger to it, it doesn't charge. If you connect it from the USB, the regular USB from the computer or something, it works. So it has to be basically 5 volts without negotiation. So a very basic USB-C power delivery. Now supposedly it has 2000 counts almost, which is very decent. It is actually very decent. 400 counts is usually what you get on the meters. Anything like 800 counts is, in my view, pretty good. It's a lot better than the average. 2000 counts is very good. I assume this is the model stuff, but I can't read Mandarin, or what is it, Chinese simplified. And so the model is YMC01. Very much recommended device. I just received it a couple days ago, so I haven't really had a chance to actually use it other than check some of my boards that I wasn't sure if the GPU is not shorted. For CPU, depending on the CPU, but typically for CPUs, it's the resistance is going to be few ohms, so beyond the capabilities of this meter. You can get this meter in 2 versions, for 2 ohms and 20 ohms, or was it 10 ohms? Yes, for 2 ohms and 20 ohms. So I chose 2 ohms because it's going to be much more accurate within that region, and that's the region that I need it for, 0.8, 0.6, 0.5. If you need to check the coils on the big motors or that kind of stuff, higher resistances, and you want to be precise, then 20 ohm meter would be better for you. You care a little less about that precision and a little more about the range. But likewise, with the meter, we can theoretically at least check the resistance of the coil. Now, remember that resistance of the coil is only one of 3 major properties of the coil. So if you only know the resistance, and the series resistance seems fine, that doesn't mean the coil is going to work. But it's better than nothing. So let's see what kind of measurement can we get on these big coils. These are 22, if I remember correctly, these are 22 microhenries. We are showing between 3 and 5. Now it's stable 3, out of which at least 1 would be the connection between the probe and the coil. So this is roughly 2 milliohm coils. That's the series resistance of it. Which means if it were shorted, we would have a difference of just 2 milliohms. So it's kind of hard to detect a faulty coil by measuring its resistance, even with this much precision. I imagine you would need even higher precision to do that, but there are much better ways of determining whether the coil is faulty or not. And that concludes the presentation. Milliohm meter, a very useful device. I highly recommend having any kind of milliohm meter. This is very nice budget milliohm meter that now is going to be my commonly used tool, especially on the laptops, measuring cores, or maybe on GPUs. In addition, as you can see, we can measure the probe, so we can check how good our probe is. And I would compare it to the oscilloscope. When you step up from the regular meter to the oscilloscope, you pretty much can do the same thing, because oscilloscope just measures voltage, right? But it measures voltage over time. This just shows you current voltage. So having an oscilloscope opens a whole new horizons for you, just like having a milliohm meter being able to measure within those regions of very low resistances opens more horizons for you, gives you a step up. Very highly recommended. No, I don't have an affiliate link. I just like to show you guys tools that actually do work and tools that could make your work a lot easier. Thank you very much for watching. I do appreciate you, and I shall see you in the next one.